Hey everybody, welcome back to 2-Min Maths. Today we'll be talking about the alternate definition of the derivative. So just a quick recap of the limit of definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. This gives us the equation to find the slope of a tangent line at any point on f of x, aka it gives us the equation in terms of x to find the derivative. But what if we just want to find the slope of a tangent line at what specified x value? We could use the alternate definition of a derivative, which tells us that the limit as x approaches c, any number, is f of x minus f of c all over x minus c, where c is the x value that we want to find the slope or the derivative of, f of x is the function, and f of c is a function or the y value evaluated at x equals c. And once you simplify down this limit, you can plug in c to figure out what f prime of c is. Let's do some examples. First up, we have the function f of x equals x squared minus x evaluated at c equals 1. And we're basically finding f prime of 1. And we can use the alternate definition of the derivative to do so. And then we can substitute x squared minus x for f of x. And f of 1 is 0. And then we can factor the numerator in order to simplify the limit. And then we can cancel out the x minus 1s from both the numerator and denominator, and the limit as x approaches 1 of x is simply 1. Remember that you can use direct substitution when you're finding the limit of a function, as covered in previous limit videos. You can do a refresher on that if you forgot. And f prime of 1 is 1, as we found from the alternate definition of derivative. Next up, we have f of x equals x plus 3 to the power of 1/3, and let's evaluate it at c equals negative 3. So we're finding f prime of negative 3. We simply plug in the following values, and we plug in x plus 3 to the power of 1/3 for f of x, and f of negative 3 is 0, because we just plug in negative 3. In the original function, we get 0. And remember the properties of exponents. We can simply rewrite this as limit as x approaches negative 3 of x plus 3 to the power of negative 2/3, because you can rewrite that as x plus 3 to the power of 1/3 minus 1, because x plus 3 is the same thing as x plus 3 to the power of 1. And then the limit as x approaches negative 3 of 1 over x plus 3 to the power of 2/3, because you can simply rewrite negative exponents as 1 over whatever the function is with that positive exponent. And when we plug in negative 3, you can see that it's 1 over 0, and 1 over 0 is undefined. So f prime of negative 3 is actually undefined. I hope this video helped. Comment down below any other math topics you'd like me to review. Thank you.